I'm Anil Kumar. Welcome to my series on review of pre-calculus. We'll understand transformations in this particular video. Here are 4 important questions to look into. Question number 1, we need to describe transformation of the graph of log to the base 6 of 36 over x if the base function is log to the base 10x. Do you see that? The bases are different. So it's a very important question. Try to write the transformations. You need to graph y equals to minus 2 times half to the power of x minus 3. Question 3 is, explain how to determine value of x that gives a minimum for transformed function in the form a equals to a sine k x minus d plus c. And the last question here is, point P is on the graph of a transformed function y equals to minus 3 f of 2x minus 1 plus 1. Find its coordinate on the function y equals to f of x. So basically I've taken up all kinds of functions which you have learned in grade 12, and I hope that will help you to give a good review. But before answering these questions, let me summarize the basics. So I've taken very basic questions here which should not be difficult for you. You need to state the base curve and describe the transformation for each. So we have 2 functions here, square root and quadratic. So let's look into these. The very first one is y equals to minus square root of 2x minus 6 minus 1. Whenever you are given a function, you should factor the coefficient of x from the function, right? So we will get factor 2, so we get x minus 3. Now if you don't factor this, you're going to get a wrong answer. Now from here, you can easily describe the transformations, correct? Now, there is a particular order in which the transformations should be described. We could follow 2 methods. One, you could go from left to right, and the other is multiplications first and then translations, correct? So there are 2 orders. Either you could go from left to right to describe, right? In that case, you land up in the correct order also. So let's move left to right here. So this minus means reflection on which axis? So outside terms are all vertical. So this is reflection on x-axis. Now, as you move inside, this 2, inside things are kind of reversed. So this 2 represents horizontal compression. By a factor of half, right? And 3 inside means horizontal translation, 3 units to right, right? So translate 3 units, right? Minus 1 will mean translate 1 unit down, right? So that is how you're going to describe it. Now let's look into the second function, which is kind of interesting. We have a parabola. Y equals to minus x minus 3 whole square. Now, I could actually rewrite this function as, look here, I'm just taking minus common. In that case, I get x plus 3 here, whole square, plus 2. Now that square makes this negative as positive. So effectively, I get x plus 3 whole square plus 2. Do you see that part? So, you know, both these negatives, they become positive. And now, I could describe the transformation without any reflection on y-axis. Do you get an idea? Right? So the transformation now, I could say there is only one basic translation, which is 3 units left. So this is translate 3 units left and 2 units up. Correct? That's it. The idea here is that, if you see a parabola, in that case, parabola is an even function. So what you understand from here is that f of minus x is actually equals to f of x, right? And that is why we could do this. So I hope this concept is clear. And now let's move on with our real questions. Question number 1. Describe the transformation on the graph of log to the base 6 of 36 over x. We have to compare it with base 10. So let's rewrite this. I could write this as log of base 6 of 36 minus log of base 6 of x, using the properties of logarithms, correct? Now 36 is what? 6 square, right? And we have log of 6 to the base 6x. Now this is 2, so we get 2 minus log to the base 6 of x. Since we have to compare with base 10, I have to change the base, correct? So at this stage, you have to change base. So this is actually a very interesting question. So if you change base to 10, you could write this as log to the base 10 of x divided by log to the base 10 of 6. So I've used properties of logarithms, right? You can change the base. Now, let's rewrite this. We have 2 minus log to the base 10. You need not write base 10, that's the default value, minus log of 6, correct? Open the bracket, so we get 2 minus log x plus log of 6, or we write minus log x plus, now that is the 2 plus log x being vertical translation up. Do you see that? Now you are in a position to describe the transformation. Does it make sense to you? So now we will describe the transformation with log x. Now this minus really means reflection on x-axis. So what we have here is reflection on x-axis, and the other transformation is vertical translation of, so I'm not calculating this value, we are writing 2 plus log 6 units up. Does it make sense, right? So that becomes the transformation for the given function. So I hope the steps are absolutely clear and you understand the whole concept. Feel free to go through this video, understand. This will also help you in first year university. Question number 2. We'll graph the function y equals to minus 2 half to the power of x minus 3, right? So I'll make a rough diagram here. So basically it is reflected and moved 3 units to right. So we can have a, let me say, we'll make a graph here. So let me use this space, correct? That should be good. Now to graph the function, we can write down the transform points. So if you consider y equals to half x, in that case, what are your key points? Let me sketch the function. Y equals to half x will be kind of like this, right? Right. So, because if x approaches minus infinity, y will approach plus infinity. So that is one thing to consider. This is this. If x is equal to minus 1, then y value is 2. If x is equal to 0, we get 1. And if x is equals to 1, then we get value of half. And then if x approaches positive infinity, y approaches 0 from top. So these are good things to consider as far as the function, the base function is concerned, right? So half to the power of x. Half to the power of x. Now, once we transform, the transformation basically here is that the x values, we have to add 3. So it becomes x original point plus 3. As far as the y values are concerned, they get multiplied by minus 2. So that is a kind of transformation, right? If you apply this transformation, then let's write down the coordinate points. These are our key points, right? So we have 5 key points. Okay. The first one, when x approaches negative infinity, y will approach. Now this will make it negative. So when x approaches negative infinity, y will also approach negative infinity because of this negative, right? On the other extreme, when x approaches positive infinity, y will approach what? 0, but from the negative side. Do you understand? So basically what we get here is that is the end behavior. You see that? So something like this. That's the end behavior. Now let's fill up the points in between. X values, we have to add 3. So this becomes minus 1 plus 3 as 2. Y values, just multiply by 2 and make them negative. So we get minus 4. Add 3, so we get 3 minus 2. Add 3, we get 4. And when you multiply by negative 2, you get negative 1. So these are your points. Now approximately, I could show my points on this graph as 2 minus 4, right? So let's say this is 1, this is 2, this is 3, and this is 4. So at 2 we have minus 4, and at 3 it is minus 2, at 4 it is minus 1. So 1, 2, 3, 4. So let's say this is minus 1, and then at 3 we have minus 2, and at 2 we have minus 4, right? So that is how the function is moving in this particular case. If x is 0, we get, let's calculate what happens when x is 0. So if x is 0 in this function, we get minus 2 times, now for x equals to 0, we get half to the power of minus 3, which is 8. So we get minus 16, right? So it's a very extreme, it's kind of like this, because this is an exponential function, so it's kind of like this. Do you see that? Where the particular point, which is the y-intercept, will be minus 16. Do you see that? So that becomes your, so this is 4, this is 3, 2, 1. And these values, as you can see here, are minus 1, minus 2, and minus 4. Right? So that is how you could actually sketch the given function. I hope it makes sense. Now you can always write domain, range, and different characteristics for this function. That should help you to review it in more details. Let's take up the next example, which is explain how to determine the value of x that gives the minimum for a transformed function in the form of, so we are given function y equals to a sine k x minus t plus c. We want to find minimum. Now, if you consider y equals to sine x, let me sketch that function, y equals to sine x. It will be something like this, right? Where the minimum occurs at this point. Now, if you are doing in radians, we know this is 2 pi, this is pi, this is 3 pi by 2. Or in degrees, it could be written as 270 degrees, right? Either way. Of course, maximum and minimum are plus and minus 1. So the minimum in sine x, in y equals to sine x, is what? The minimum is 3 pi by 2, and the value is minus 1, correct? Now, if you make the transformation, then what happens to the points? The a value and the x value changes. The change is kind of like this. As far as the x value is concerned, we get 1 over k times the original x value. It moves d units to the right. And the y value becomes a times y value plus c. Right? So the new coordinates will be, so the minimum will be at, we'll have this point at 3 pi by 2k, right, this k value, plus d, and the value will be minus a, which is minus 1, right, plus c. You get it? So that becomes the coordinate for this point, right? So that is how we could do it. Well, in case they want a general expression, then we can already write plus 2n pi, where n belongs to integers, right? So that could be your answer. I hope that makes sense. So let's move on and take the next question. It says point P 4 minus 6. So we have a point P, which is 4 minus 6, is on the graph of a transformed function, graph of y equals to minus 3 f of 2x minus 1 plus 1. Find the coordinates on the function, that means on original. So we have to find coordinates on original. Okay, so let's get back to this. We could factor and write this as 2 times x minus half plus 1. So if the coordinates are x0, y0 in the original, then on this function they will be half of x0 plus half, right? As far as y values are concerned, minus 3 times y0 plus 1. So those are going to be the coordinates. Now these coordinates are given to us. We are given these coordinates as 4 and minus 6. Now from here we can find the original coordinates. Do you get this idea, right? So relate these two. So let's calculate. So what we know here is that half of x0 original plus half is equals to 4. If you multiply by 2, we get x0 plus 1 equals to 8. So the original point x0 is 8 minus 1, which is 7. Let's find the y value also. So for the y coordinate, we have minus 3 y0 plus 1 equals to minus 6. Taking 1 to this side, we get minus 3 y0 equals to minus 7. And this gives you that y0 equals to 7 over 3. And therefore, on f of x, the points should be 7, 7 over 3. Correct? So that is our answer. So our answer is 7, 7 over 3 will be the points on base function. Is that clear, right? So that is how it can be answered. And that brings us to the end of this series on transformations. I hope with these examples you learn the concepts and it is kind of a good review for your final exam. We purposely took few questions relating to logarithms, exponential and trigonometric functions, since you learned those as you went along this course, and I hope it helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thanks for watching and all the best.